Hello everybody, welcome back to Math 245. Hope you had a fantastic weekend. This is lesson 21, the first of two lessons for Monday of week 5. It's hard to believe we're already in week 5. Time flies when you're having fun. So once you're done with this video, go on and pop over to lesson 22. Today we are going to talk about more about sets. So last week we talked all about sets and different things that we can do with them, and we are continuing that this week as well. So here we're going to talk about the number of elements in a set. We have a couple definitions to start us off. The cardinal number, or the cardinality, for a finite set A is the number of elements in A, and we denote this N of A. Whoops. That is just the number of elements in the set A. A union B, that's how we read this symbol right here, A union B represents the union of the set A and the set B. The union of A and B contains all elements that belong to A or B or both. So we'll do some examples down below to practice this. But the union of two sets is just everything in either one of the sets. A intersect B, that's how we read this symbol right here. That represents the intersection between A and B. The intersection of A and B contains all elements that belong to both A and B. So these are the elements that A and B have in common. So these definitions will help us out with our rule here, the union addition rule. So if I have two sets A and B, then the number of elements in the union of A and B, that is what this represents, the number of elements in A union B, is the number of elements in A plus the number of elements in B minus the number of elements in their intersection. So the reason that we have to subtract this guy off is because if I have some elements in common between A and B, then this right here would be counting those elements twice. I only want to count the elements that A and B have in common once, so I have to subtract off the number of elements in their intersection. That way we only account for all elements exactly one time. So let's do some examples here. If A is the set 3, 8, 13 and B is the set 3, 6, 12, 15, let's first determine A union B. So A union B is everything in A and B. So I have A, which is 3, 8, 13. And then I have B. I don't count that 3 twice because I already counted it once. So I just have 6, 12, 15. So then if I wanted to determine N, or the number of elements in A union B, well, in this case, I can just count them. 1, 2, 3, 4, 5, 6. But I could also figure this out by using our rule up here. So this is the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. So I see that in A, I have 3 elements. In B, I have 4 elements. And then this last piece is how many elements do A and B have in common? Well, they have 1, 3, right? So the number of elements that A and B have in common is 1. So I get 6 again. In this case, we can easily just count the number of elements in the union of A and B, but I can also practice using this union addition rule. Let's do a couple more examples. I have sets T and S here, and I want to know the number of elements in S union T. So let's first determine what S intersect T looks like. So these are all of the elements that S and T have in common. I see that I have 3 in common, 6 in common, 12 in common, and 15 in common. So here, S union T is 3, 6, 12, and 15. So the number of S union T, the number of elements here is 4. So then the number of elements in S union T is the number of elements in S minus the number of elements, plus the number of elements in T minus the number of elements in S union T. All right, well, S has 4 elements, 3, 6, 12, 15. T has 1, 2, 3, 4, 5, 6 elements, and they have 4 elements in common. So total, this gives me 6 elements. So here we can see pretty clearly why I have to subtract off their intersection. So if I didn't, then I would get 4 plus 6 as the total number of elements in their union. But S and T have 4 elements in common, which is all of S. So if I did not subtract off their intersection, I would be counting 3, 6, 12, 15 twice, once in S and once in T. So that's why I have to subtract off this guy right here. All right, one last example here. If the number of elements in X is 21, the number of elements in Y is 16, and the number of elements in their intersection is 9, then what is the number of elements in X union Y? Here I don't have the actual lists to see what kind of elements I have, but I do have enough information to solve this problem. So the number of elements in X union Y is the number of elements in X plus the number of elements in Y minus the number of elements in X intersect Y. Well, I'm given that n of X is equal to 21, n of Y is equal to 16, and n of X intersect Y is 9. So I have 21 plus 16 minus 9, which is 28. So as long as I know these 3 things, how many elements are in each of the sets and their intersection, I can determine the number of elements in their union. All right, that is it for this lesson. Go ahead and go over to lesson number 22. That's our next one. See you there.